Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So, had somebody in the comments mention a soldering chat, so I figured what a good opportunity. I actually was out spending money on Aliexpress, and I came across this kit. Let's see here. It's an LED level meter. This didn't print out very good, but the title is a DIY Kits Voice Control Indicator, 3 level sections, 10-point indicating LED, red, blue, green, electronic production kit. And what it is, it's an electronic level meter, and it has 3 bands, high, medium, and low. And each band has a different color. So there's 3 strips of LEDs, and it has a built-in microphone and a little power supply, so it's picking up noise from the room, and then it converts it into like a bar graph display on these LEDs. And it was a cheap little thing. I paid $8 a piece. I bought a couple of them. Why not? If I ever do decide to integrate this into an amplifier kit or a project I'm doing, I could use this as kind of like an output level meter, or just something that gives you blinky lights you like looking at. So yeah, I bought this on Aliexpress, and you can see the price there. I paid in Canadian dollars. You probably get it cheaper if you're in America or the United States. They had free shipping on orders over $10, so I bought 2. Why not? And here they are. And looking at this, they are kind of a complex device as far as a kit's concerned. There's a lot of soldering. So let's pull one of the boards here and have a look at it. You see the printed circuit board here is well marked out. A lot going on here. It's very busy. A lot of holes, a lot of pads to solder. So this is a good project kit if you want to practice your soldering skills. And you get this board is actually very nice construction. It's got solder mask and everything, so it shouldn't be too difficult to solder up, even for beginners. The pads are pretty small, so you need a fine tip on your soldering iron, but I think by the time you're done with this, you're going to get some experience on how to solder a kit together. So that's kind of the reason why I bought it. I thought it was interesting too. It has the 3 bands of LEDs. I'm kind of curious on how that works. Let's look at the schematic. This is the schematic I got from the Aliexpress site, and we can go over it quick. So up here we have power supply. There's a input blocking diode, a reverse polarity blocking diode, so you can't feed negative inputs into this and blow it up. So this is protection here, and then it runs into a 220 microfarad cap for filtering, and then a 3-terminal regulator, and then another 220 microfarad cap, it looks like. So pretty basic, simple power supply. Here is the input circuit, and then we have a condenser microphone here, and it's being fed with a biasing voltage through this resistor. And any signal that comes in here, audio signal, gets converted to electrical, flows through this capacitor, goes through one stage of amplification, and then there's a level potentiometer here, a blocking coupling cap, and then it goes into a second stage of amplification before it heads out to the 3 bands. So what it looks like is going on here is we have a couple transistors on the front end of each band. We got high, medium, low. I don't know which one's which because I can't read any of the values on this schematic. When I blew it up to fit the sheet, so it's poor resolution. But we have a volume potentiometer for each band input, and our signal comes from our amplifier up here and feeds into these 3. So we have independent adjustment for each band, and then it looks like it goes through a 2 transistor amplifier for each band, and then it goes up to this configuration, this display configuration. And this is kind of simple. It has an LED on each transistor. Each transistor turns on or off the LED through this dropping resistor. And the idea behind this is your signal at this point is amplified by these transistors, and then it gets sent out on this line. And then we have this ladder of diodes here. There's a series of diodes. So in order to light up these LEDs, we have to have an increasing voltage to overcome the forward voltage of each diode. So if each diode is 0.6 volts, you can figure, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 diodes. This first transistor doesn't have a diode. So we have 10 LEDs, right? First transistor is connected directly, and this one will light up on any signal that's 0.6 volts or below or above. And then after, we have to have an increasing voltage to get each LED lit. So for example, to light this LED, we have to have a 0.6 volt, more than 0.6 volts on this point here to light up this LED and this LED. If we want to go farther, we have to go 0.6 is 1.2 volts, so we have to have 1.2 volts to get the second LED lit, or the third I should say, and then so on and so on, all the way up to the top where we have 9 LEDs, so it's about 5.4 volts here of signal to light up the whole string. I don't know if I explained that right. Probably not. My point is, as we increase the voltage here, you can slowly increase the voltage here, then you'll get more and more LEDs lighting as the voltage overcomes the string of diodes that have a 0.6 volt forward voltage. And they do that 3 times through 3 bands. So pretty simple circuit. So let's warm up the iron and let's start building this thing. There's a lot of resistors. You can have a look. So we got resistor, 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 LED, 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 transistor, transistor, transistor. Then we have more resistors, and our diodes are in here too. So let's see. This is the one we're building, I think. Let's dump this out. Okay. So here's a bunch of resistors. What do we got? These are These are 560 ohms. Green, blue, brown. 560 ohms. So we should have a number of those. Probably, I think it's 15. No, be more than 15. It'd be like 30 maybe. I don't know. I'm going to count them. These ones are 4.7K. These ones are 2.2K. 33K, 10K, 47K, and then we have a few miscellaneous parts. This is all our transistors and LED or diodes. All these transistors are S9013s. Now I don't know, I think the kit uses all the same transistors unless there's something. No, 9012. So what's the difference here? We've got 3 of these. 9012. Yeah, so where are these being used? So I can't read this. Green LEDs, blue, red. This is going to be interesting because I can't read any of the values on this. I guess I can read them here. Transistors Q, it just says Q26, 28, 30. Q1, Q2, Q3. Okay, here's, it's marked 9012 here, 9012, 9012. So I'm assuming Q4, Q5, and Q18 are the 9012s. Okay, I'll have to remember that. And then the rest will be all of these, which are 9013s. I don't know what the difference is between the two. I should look up a data sheet for these. Let me get a data sheet for this and I'll have a look. Okay, I'm back with the data. So now I need to understand what the difference is. The 9012 is a PNP transistor and the 9013 is the NPN complemented, I guess. Yeah, they're complementary to each other. If you look here, they're both the same transistor but just complementary. So that makes sense. And if I look at the schematic, I can see that they do have 3 PNP transistors here in these positions. Okay, so that's cleared up. So we can start. What I'm going to do is I'm going to start with the smallest devices first, components, and then work my way up there. So that's diodes first, then resistors, and then we can work on filling it with transistors and LEDs after. So let's start with these. And haven't built, well, the last kit I built was at Christmas there. I built that yeah, I can't even remember what it was I built. So let's just start stacking diodes here. This might take a while. Okay, I'll bring you back in when I'm done. Alright, got 30 diodes installed. I think I got them all. I can make sure they're all in the correct orientation. And have 2 extra, so that's okay, I guess. I don't think there's anywhere on here that uses, like I'm looking at the schematic and there are only, if I can count up 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 3 is 30, yeah. So I think we got them all and we have a couple extra, so I'll throw these back in the bucket. Don't need them, and we can start soldering. So I think I got them all mounted close to the board, and we can start. Let's see here. Okay, so what I'm going to do is just start from one side here. Just force the wires sticking up. Comfortable. Now there was one guy that I always read the reviews of these kits and stuff I buy on Aliexpress, and people write reviews. They buy the kit, they build it, they write a review. And there was one pretty good reviews, I guess. It's one of the reasons why I like these, because, you know, people are honest in their opinion. There was one guy that had it, he said he had a problem. He built it and one of the strings of LEDs wouldn't light up. It would only light up halfway. And I was thinking, what would cause that? And I think I know. I think he got one of these diodes in backwards in the middle of the string here. because that would prevent the voltage from getting through. It would get through up to this point, light up these LEDs, and then if this is backwards, or maybe it was broken or damaged, the diode's damaged, then these LEDs won't light. So, but there's no way for me to reply to his question regarding his faulty board or faulty kit. But if he's watching, that's probably what it is. That's my guess. I'm just guessing. Okay, I think I got all of these. Okay, so let's cut these ones first. Let's mow the lawn here and get rid of some of these wires. And then that'll free up some space. I can solder the next row. Okay, how does it look? It's looking good. Make sure they're all flat to the board. That's what. Here's one that's sticking up. You see any other ones that are sticking up? I don't think so. Look pretty good. All right, let's do this side. So I bought the kit with this in mind, and maybe using it, incorporating it into maybe a homebrew amplifier or something. I could put these as the output display. I don't know. Tell me what you think. Is flashing lights cheesy, or is it cool? Or people loved having amplifiers with meters and level meters on them, both the analog needle movements and the digital display. I know the Pioneer used to have the fluorescent level meters, vacuum fluorescent display, and people still go nuts over those today, just for the blue light and the action of the lights when the music's playing. This is LED though, so this is using modern LEDs. They're probably brighter than they need to be, and blue, green, red. They're probably pretty harsh to look at. You probably want something that's more, well, let's see here. We're going to see when it's done, but they're clear LEDs, right? So they have a really bright spot of where the light gets emitted from, and some people find that objectionable, a little harsh. Almost be better if they put a frosted LED in, and it gives it a softer light. But that's just personal preference, I guess. Okay. Just put on this row. Okay. Getting there. Okay. Again, I'm going to check. Okay, do the last row. And then we can move on to resistors. Board's pretty easy to solder to. It's the solder mask, it's pre-tinned, so you shouldn't have any troubles that way. You just got to watch out for bridges. Don't use too much solder. Usually if you use too much solder, you're going to run into problem with bridges. Okay, I think that's it. I know it's supposed to be a soldering chat, but I'm not doing too much chatting. Kind of just sitting in limbo today. Today is April 27th, 2025. So, all right. Now, let's move on to something else. Let's move on to resistors. We got 7 33K resistors. I don't even know if we have. I saw one here. Where was it? $33K right here. And do we have any other ones? $560. I don't see any other 33Ks. I saw the one. Oh well. Put those aside for now. Let's try 4.7K. Okay, I see quite a few of them here. 4.7 here. 4.7 here. Seven here. Yeah, so like I was saying, today's the 27th of April, 2025. Tomorrow's April 28th. Very important day in Canada's history. We're going to have an election that's going to determine the fate of the country. And everybody's on pins and needles. And it is a very important election. It's not like just any other election. It's going to set our path for the future. And if it goes the wrong way, well then, adios. But if it goes the way we all are all hoping it goes, we can get this country back on track. The last 10 years have been a complete failure as far as our country is concerned. It's a joke what has happened in the last 10 years with... No, I'm not going to get into details. I'm sure some of you know exactly what I'm talking about. Some of you that don't know, well, maybe you need to educate yourself. But yeah, it's going to be an important one, and there's no turning back. So everybody's kind of anxious to get this over with, and I have a good hope that it is going to go the way that we need it to go. And for our American friends, I'm sure you guys have your own opinions, but I'm not going to talk about American politics on this channel for sure, because I'll upset a lot of people. It's not something I'm fully up to speed on. I do pay attention, but I don't pay enough attention. And there's a lot of stuff going on that probably I don't know about, shouldn't talk about. All right. So let's see here, we got a few left. Just populating all the 4.7Ks here. Now I was looking at the schematic here and did not see how they're doing the different band paths for each band. If I can pull this up a bit so you can see it. I think what they're doing is they're doing a capacitor. Yeah, I'm not sure how they're doing it. I can't read any of the values here, so it doesn't make any sense to me. So I got 3 more. Get these 3 in and then we'll solder this up. Alright, got our 4.7Ks in. Let's solder these. How are we doing for time here? Okay, so we're probably around the half-hour mark. I don't know if I'll show all the steps. I'll show these resistors going in and then I'll cut the camera and we'll put the rest in. I know a lot of people get bored easily. Or they complain that the video's too long because their time is so precious, that they need to be doing something more important. But I question, why are you on YouTube if your time is so important? And people come to YouTube for entertainment, education, and maybe sometimes just to kill time. If they have free time, they want to... Ooh, that one. Okay. I'm sure you guys all have your reasons. Did I miss any? Yes. Okay, I think I got all those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Great, finish this up. A couple left. I like to go through and do one value at a time, and that keeps me from mixing them up, I guess. Okay, you got them all? One, 2, 3, 4, 5, 6, 7. Yep. Alright, 4.7Ks installed, diodes are installed, and I'll go through and do the rest of the resistors off camera. I got quite a few here. You see all the resistors, and I'll bring you back in. I'll show you what that looks like. Alright, resistors are all in, and you can see it's just a sea of resistors and diodes. A lot of parts here, and yeah, this is going to be a bit of a challenge. Some of these pads are very close together, and if you're not careful, you're going to have a solder bridge, and also it's good exercise for your eyes, I guess. Make sure that there's no solder bridges. Make sure all the pads, none of the pads get missed, and yeah, very interesting. I'll have to, when I'm done, I'm going to clean this and then we'll give it a good exam with a lens. But right now I'm working on, well, let's put this diode in place. This is IN 007, and that goes down here. This is the input power blocking diode. Let's put this one here and solder it right now. Now I'm going to start doing some of these caps. I had an extra resistor left over. I don't need that. Some of these caps here. So this one here is 10 nanofarad, 103. Let's see. 103 right here. Okay. What is that? 102. 1 nanofarad. 104, 104. All the caps should be around here. 104. I'm not seeing it. 102. Where are you? Oh, 104. 104 right here. Triple 2, which is a 2.2 nanofarad, I think. What do we got here? 103. This is definitely a good exercise for your soldering skills, that's for sure. It gives you a good workout. 104, where are you? 104. And another 104. There's 102. 104 is right here. 102. C7. Looking at some of these caps, some of the electrolytics, I think I might be replacing some of these. They don't look very high quality. That's the problem with some of these kits, is the part quality they use is subpar in some spots. They just put absolute minimum part in. I think I got them all. Yes. All right. Caps are in. Small caps anyway. Some of these electrolytics, though, I'm not good at them. These are China brand, Wuhong, Huahong. This is a 220 at 16. Let's see what it says. Oh, it reads 191 microfarad. And what's our ESR? Okay, 190 microfarad. It's not the greatest. Where's the other one? This one's 189. About a third of an ohm. .7 microfarad. Let's see what this one reads. 4.1. I guess they're okay for what they're going to do. All they're going to do is make some blinky lights, so you know, it's not like we're putting audio through this, and we're not going to be critical of what comes out of the circuit. So I guess they're all measuring about 4 microfarad. That should be all right. I think for right now I'm going to put these 3 PNP transistors in before I forget and before I mix them up with the other ones. So let's get them out of here. One, two, and 3. Check and make sure that they are all the 12s. And they are. And they go into this spot here. All right. Right. Put those in. What I'm going to do next is I'm going to populate all the rest of the transistors and solder those in, and then I'll bring you back. Do we want them standing nice and straight? Alright, all 38 transistors are in. It didn't take long actually. It's actually a little better than what I thought. Better than the resistors. Resistors are a bit of a pain to put in, but these ones are easy. Pop them in and solder them up. Now we got left, we have electrolytics and trim pots, microphone. Oh, the LEDs, I'll put those in last. Let's do some electrolytics right now, 4.7s. Yeah. I'm assuming the shaded portion is your negative. Yeah, because it's marked positive. Okay, I got it. I got it. So let's put this together and get this thing fired up. I had 2 extra transistors left over, by the way. So they've supplied 40 and you need 38. Unless I missed one. I don't think I did. I'll find out at the end if there's any open holes. What you do is you hold it up to the light and you look through the board and you can see any open holes. It will stand out immediately. And Then you'll know if you missed a solder joint or if you missed a component. Let's see here. And I tested these caps. They're not great. They're not high quality caps, but they're not so bad that you can't use them. So we're gonna go use them. And the two big ones. A part stuffer. That's what I'm a part stuffer. Kind of like a chicken plucker, but it's part stuffer. Okay. And you gotta remember, back in, what was it, back in the 60s, when did they start using printed circuit boards? Probably around 1960s. They started to become common. They were brought in to make electronic assembly cheaper and faster, right? Instead of doing point-to-point wiring. Because before that, you had somebody sitting at a bench with an iron and doing point-to-point wiring with pair of needle nose pliers or whatever, and they had to make sure every joint was good, otherwise the item wouldn't work. And then they sat and did point-to-point wiring. It must have took them a long time to do a simple, like a 5-tube radio or something. It must have took them a long time. But then they brought in printed circuit boards, and it sped up things a lot. All you do is you get your part stuffer, and he stuffs the parts on the board, and the next guy comes along and solders them, I think. Or maybe they both, the one person does it all, I don't know. And then they developed automation, which is your pick and place machines and wave soldering. So they solder the entire board in one pass. It was all brought in to help speed up manufacturing and increase profits. Okay, I think I got them all. Oh, I missed one. Right here. Now I got them all. All right. We've got 4 trim pots. They're all the same. They are 47K. So let's put these in. Okay, bottom these out. All right, condenser mic. How do you tell positive from negative on a condenser mic? Well, I have a feeling, I'm not 100% sure. But if you look at this microphone, there's two terminals. This one here on the left has traces running out to the outside, which is attached to this aluminum cylinder. So that's what I'm assuming is your ground, and then this would be your positive or your signal. So you apply a voltage to this, sound waves go in, the capacitor, it's like it's a condenser, it's called a capacitor, and as the diaphragm wiggles with the vibrations of the sound, it creates a little variable voltage on this one here, because you're biasing this, the outside is at ground, you're biasing this positive pin with a voltage, and the capacitor is going to wiggle and change that voltage. So that's how they work, and then you have a very small signal coming out of it that you have to amplify. So I'm just going to bottom this thing out because it's not. There we go. Voltage regulator is a 7806. I don't know if you can read that. And then we have our input for the power. Now we'll just leave it like that. This one. Put that there. We can solder these two. Okay. Solder these two home. All right, so we are done everything except for LEDs. Now we have red, green, and where is the blue? So I'm going to put red, green, blue. I'll populate these and then I'll bring it back. I don't know if any of you know this, but if you look at an LED, you're going to see one wire longer than the other. And it's the same for electrolytic capacitor. One wire will be longer than the other. That's your positive lead. Same thing for an LED. The longer lead is your positive, and it has a flat on the opposite side, which is your negative. So the board is marked here with flats on the left. Let's see. So that should be correct. Alright, I'll load the rest of them up. So what I'm going to do is I solder one leg of each LED, and then I flip it over and check it. And I can see I got one wonky one here. The rest of these are nice and straight. I got one wonky one. So we're going to fix this wonky one up. There we go. Just so it, there. Now I can solder the other lead. Keep them all straight, make it look professional. Okay, next is green. I noticed they supplied me with 11 LEDs in each color instead of 10. I guess if you get a burned out LED or one that's defective, I guess you can't complain. But for right now, we'll just load these up. Okay, just finished with the LEDs. They're all in, and I just held it up to the light, and I was looking through the board, and there's probably about 5 joints that I need to repair because they don't have adequate solder. Not enough to flow around the lead and the pad. So this one here, and then there's a few other ones. Where's the next one? Next one's right here. I did run the soldering iron over them, it just didn't get enough solder on these pads. It's too little. So I'm just going to fix up my goof ups right now. There's 2 more. One is right here. Whoops. See, now I created a bridge. Okay, that's better. There's one left. This one right here. Okay, let me check. Up against, oh, we still got one more. Right here. Still got more. It's a good thing to check these because and then I think I had one here. Another thing you gotta watch for is bridges. And bridges will get you. Alright, I think I have all, no, I still have one more. I don't have any that I missed. It's just they're very, very light on the solder. Okay, I got them all this time. Or did I? Okay. Solder bridges, you're going to have to use your eyes and a magnifying glass. I'm going to take this, let's clean this. Everything's on, right? I'm pretty sure everything's on, yes. Now you don't have to do this. I do it because I like to, it makes it easier to inspect the condition of the soldering. Just put some alcohol on here and just scrub it. I might take a couple passes here. Don't look like you have too much flux on it. Just absorb all that. And it's looking a lot better. I just clean it one more time, especially around here and this edge. I'll just give it another cleaning. Two cleanings is good enough. I rarely clean a board more than twice. If it don't get it on the first one, the first cleaning usually takes care of all the majority of the flux, and then the second cleaning comes and cleans up the remainder, the last few percent. Okay, that should be good. That looks nice. Alright, let's power it up. See what it does. Alright, so we have a 6-volt 3-terminal regulator here. So you're going to have to supply this with at least 7 volts because you're going to have a 1 volt drop within the regulator. Before the regulator starts to regulate, you're going to have at least 7 volts here. And this first input capacitor is a 16 volt capacitor. So you don't want to exceed this. Well, let's see right here, you got 0.6 volt drop on that diode, and then you have this your 3-terminal regulator. So if you feed 16 volts in here, you're going to get about 15.4 volts across this cap, which is right at the limit. So you don't want to exceed 16 volts here. So our power supply is between 7 and 16. I'm going to feed it with 12. Got 12 volts here on a power supply. Make sure these don't short out, and then when we plug this in, it should all start working. Where is this way? Oh. It's a really tough connector. What is going on here? Doesn't want to plug in. Oh, it's tight. There we go. Why isn't it working? Hello? You buggered it up. Oh, okay, maybe my hands are... Well, green is not working very good. Red is not working at all. Let's see if we can get this thing working. Blue's working. Okay, so that's counterclockwise. This is clockwise. Okay, that turns the volume down. Why is blue so sensitive? Let's give it about half. Wonder why we have 2 LEDs on. These transistors defective? The green is working, but we have current leakage on these 3. Let's turn up red. Hello? Yeah. So red's turned up. Green's turned up. Hello? And blue. I wonder if it's picking up some kind of stray noise. Hello? Hello? So you get to fiddle with these. We need to figure out what's going on with this. Power supply shorting out. It's getting better. I wonder if it's a transistor. Because it shouldn't be on. I'm going to swap one of these transistors, especially this one, with one of these, and see if that light goes away. We might just have a bad transistor included in the kit, or a couple of them, because these ones seem to be turning on even though they're not getting a voltage. Because the one before is not getting a voltage, it's working properly, but these ones... Give me a minute, I'm going to yank this transistor and replace it with this one. Let's see what my little Chester says for this transistor. You can't read that. It says 386 HFE. Okay. Let's try a new one, because they gave me 2 extra new ones. $354. 14 microamps. Collector emitter open, 14 microamps. Can't remember what it was. $14 microamps. Doesn't measure leaky. Let's put this one in, solder it, and see if that phantom light goes away. So I'm replacing it with a new transistor, because I had extras. All right. Seems to be working now. We don't have any more phantom light on green. Hello? Hello? It's working. I wonder if this transistor was bad. But the other 2 beside it were lighting up as well, so maybe it was back feeding current. It's not possible. It can't happen that way. The diode would block it. It is weird. It's working now. Okay, so this thing's purely microphone input, but if you wanted to make this, let's see here, let's get this out of the way. If you wanted to make this to feed a signal in, I guess you could do a few things here. You could try feeding the signal in at this point. This little amplifier here. I don't know what kind of signal's coming out of here, and this is your volume control here. And then there's a coupling cap. So you could do it just before the trim pot, or you could do it after this entire stage and feed it in here, probably right here, after this cap. And just, I don't know, you turn this down so you wouldn't get phantom readings from noises. You just want your music to trigger this. So, yeah, I would inject the signal right here. Other than that, it seems to work, and it seems to work good. So I'm just going to call this a win. And yeah, it's picking up a lot of my... I wonder which one's the low one and which is the high. I don't know. Tell me what you think. Some of these LEDs are scratched. Alright, so I'm going to end this here. Thanks for watching. Tell me what you think down below. If you guys want to see me build a kit, give me some ideas and I can go out and look for it. And we can make a video. That'd be an entertaining way to kill an afternoon. Alright, take care. Thanks for watching. We'll see you in the next one.